Hello, welcome to F-Grade Electronics, where we try to fix broken electronic devices. Okay, we have the number 4 of our power supplies. We tested them before, and this one was open circuit. Let's confirm it. Yeah, it's open circuit, no current flow. I'm using a light bulb in series to check that. No current flows. This one has been opened before, as we can see. Let's open it and try to find out what's wrong with it. This one probably has a blown fuse, like the last one. Okay, let's put the upper case aside for now. Cable tie is out. Okay. Okay, the board is out. I'm going. Oh, look at this. Look at this. We only have one cable. What's going on here? We only have one cable from the wall. Where is the other one? Yeah, someone has worked on it before. It looks like. Where's the other cable? Look. There's only one. Yeah, the fuse looks blown. But we are going to check it anyways. I hate when this happens. Let's check the fuse. No, the fuse isn't blown. Where's the other cable? Okay, let's check for a short. Do we have a short here? No, we don't. Yeah, this part is the rectified positive. Let's also check the bulk capacitor. Yeah, we don't have a short here. I'm going to check the MOSFET and the diode. Yeah, we have something here. Okay. Okay, these two are the mains switching MOSFETs which drive the transformer here to create 12, 5, and 3.3 volts. And these look to be short, but we have to get them off the board to check out of the circuit because maybe something else on the board is shorted and we are seeing it, but if we check out of the circuit, we can identify whether the short is on the board or on the MOSFET. Let's desolder this heatsink and all the MOSFETs and our diode. The switching MOSFETs, the active PFC MOSFET, and the active PFC diode. Here we have our MOSFETs and the diode desoldered. Let's check them out of the circuit. We're in diode mode. Let's see. We shouldn't see anything here. We are seeing something here. I'm going to explain it. And we should see a diode value from here to here. But this one has a very low value actually. Yeah. Let's see. Yeah, it's normal now. Okay, let me explain why we saw a lower value. Now we don't see anything, but if we apply some positive voltage from the gate to drain, this starts letting current pass and we see a voltage drop here. Let me show you. Now we see a voltage drop and this one is decreased because of it. Now we still can see a voltage drop because these devices have some capacitance between the gate and the drain. That's why we still can see a voltage drop. But if we apply a negative voltage from gate to drain, we no longer see a voltage drop and the diode inside has its normal value. This shows us that this MOSFET is doing its job. Let's check this one. I'm going to test it now from source to drain. We have nothing. Let's apply some voltage here and we can see a voltage drop. Normally this starts conducting, but the multimeter has so little current. You can only see something like this and But let's see, I'm applying some voltage. Let's see the diode value here. Yeah, this one is also working. And let's apply some negative, and we don't see anything. And the diode has its normal value like this. Let's test also this one. These all be same. Yeah, these are ITA 13 and 50 13 and 50, 500 volts MOSFETs and channel MOSFETs. Let's see. And we have a value here. Yeah, we see a value here. Yeah. Let's apply some negative, and we don't see anything, and we see that. So these all look normal, and let me show you something on the board. Let's get the board back. Okay, just to see, I desoldered the transformer here, and we don't see anything now here. Why we were seeing a low value was actually because of the design. You see, we have a controller here, and this controller is connected to this transformer via these two legs, and we have transformer like this. I desoldered it to check whether the value was because of it or not. And if we check now, we don't see it, but actually we would see the same value from here to here. We can't see it because it's desoldered, but what's important is this has only one output. This one, only one PWM output, but we want to operate these two MOSFETs asynchronously. That's why we have two coils in reverse. So think about it like this. When we have a positive PWM signal from here to here, let's say we are going to get a positive voltage on this side, and this gate opens, and the other one is going to have a negative voltage because it's in reverse, and this one is going to close. This one won't let the current pass, but this one is going to let the current pass. And when the PWM signal is reverse, this one is going to have a negative voltage and the gate is going to close. This won't let current pass, but this one now is going to have a positive voltage on its gate, and it's going to let the current pass. What I'm saying is a low value between the gate and the drain is normal because we have a coil in between. But when I desoldered it, I saw a lag wasn't connected properly actually. That's why I'm going to solder a new leg onto this coil, this transformer, and check with cables to see whether this power supply works or not. It might be because of a lost connection between the transformer and the leg. If this leg isn't present, let's see, it's going to go like this. Yeah, the controller won't be able to control the gate of this MOSFET right here, this MOSFET. So it won't switch the transformer here, and we won't have any current on the low voltage side, any voltage on the low voltage side. So let's solder a new leg, solder 2 wires, and see what happens if we try to turn it on. The board is reassembled here, and I also resoldered the leg for this transformer here, transformer for signaling the gate of these MOSFETs from this controller. Normally you can directly connect the controller to the gates of the transistors, but this is for the isolation and it's used here. Let's cut the excess like this, and let's clean the board using some isopropanol. Okay, and I also used another socket for the mains voltage. And let's see how does it react if I try to turn it on, or at least connect it to the mains. It's on. Let's plug the cable. I'm going to use the light bulb in series. Okay, let's see. It just flashed. This is totally normal. Let's also turn the overhead lamp on. Get our multimeter, voltage mode. I'm going to probe the ground using the Molex connector. The middle 2 pins are ground. And let's get the 24-pin ATX connector. It's here. Let's Something's wrong. Something's totally wrong here. Do we have 5 on standby? Yes, we do. Do we have PS on? Yes, we do. Do we still have it? 5 on standby. Let's see. I'm going to use the light bulb in series again. Yeah. It's continuously flashing. This is not normal. Let's shut it off. I'm going to try to turn the power supply on. Okay. Let's try the light bulb again. It flashed only once this time. It's directly connected to the wall. It's connected. Do we still have 5 volt standby? Yes, we do. Do we have PS on? Yes. Let's see. I'm probing 12 volts from the plus 4 connector here. This is the plus 4 connector. And here is our 12 volts. Let's see, I'm going to try to turn it on. We have 12 volts. We have 5. Here. We have 12. We have 5. We have 3.3. Looks like this one is working actually. Let's turn it off. But I don't know why it kept flashing. After the capacitors are charged, it should have flashed only once, not 5, 6 times continuously. Let's try it again. It only flashed once this time. Yeah, and it's holding the charge. It doesn't flash again. Yeah, even the multimeter is affected from the magnetic waves. Turned on. Yeah, but it's not connected to anything actually. It was only connected to the ground. The probes are here. Let's see. Let's wait for it to drain. Let me show you the voltage on the bulk cap while we are waiting. Yeah, it's 40 volts now. The light bulb flashed. Okay, we need to actually try this one on load, under load, however you want to call it. And we need to reassemble the casing and connect it to a computer. Let's do it. Here is our power supply working. Number 4, the open circuit one. Actually, as we saw, it wasn't an open circuit. Someone got the cables out. For what reason? I don't know. I've been testing this power supply for an hour and 50 minutes, as we can see on the screen. It's been running Permark and Prime 95 for almost 2 hours now. I plugged it to the motherboard, got some tea, waited, and here we are. It's working. The 12-volt line is healthy. I don't know what to say. Maybe this wasn't broken at all, but someone still used the cables for something else, I don't know. Or maybe the leg of the transformer was not soldered properly. I desoldered the transformer and the leg came off by itself. Maybe it was broken before, maybe I broke it. I don't know and I can't know. Maybe this was this power supply's fault. Maybe it wasn't faulty, but still. Someone got the cables for something else. Yeah. If you have any questions or you want to suggest something, please let me know in the comments. Please like the video if you liked it, or dislike it if you didn't like. Thank you for watching. We'll see each other in the next video. Goodbye.